Alrighty, so the first question we're going to work on is this simplifying indices question. This is quite a straightforward one. So what we have here is 4x squared y times 3x y cubed. Now what we need to remember with each of these is there is actually a multiplication sign in between each of these. So what that then allows me to do is then rearrange this so I get 4 times 3 times x squared times x times y times y cubed. What I can do from there is just do each part individually. So I can just do 4 times 3, which in this case is going to be 12. I'm going to do x squared times by x, which is going to give me x to the power of 3, because remember there's an imaginary 1 there. We add our powers when multiplying indices. And then this is also like y to the power of 1 times by y to the power of 3, which gives me y to the power of 4, and that is my answer. We then just scroll down to have a look at question 2. We have, I'm just going to zoom out a little bit, we have 4k cubed over k to the power of 7, all to the power of 2. Now what I'm going to do, I'm going to apply this power of 2, this one here. Remember that needs to get applied to the 4, to the k, and to this k here as well. So that actually changes this to be is 4 squared and then k to the 3 times 2 over k to the 7 times 2. And I can simplify that to be 4 squared is 16, 3 times 2 is 6, and then k to the 6 over k to the 14. Now from here, I have 6 k's on the top, I have 14 on the bottom. That means when I cancel these out one for one, they're all going to disappear. I'm going to take away 6 of these ones. I'm just going to turn this into an 8. So from here, my final answer will be 16 over k to the power of 8. And that's my answer just there. Next, I'm going to look at number 3. This one's starting to get a little bit trickier. What we need to do here is I need to just straight away start simplifying these. Now with this one, what I want you to do, split it up into its numbers. So first of all, our numbers, we have 20 and 15. What I can do then is I can go times by c negative 3 over c negative 1 times by d squared over d negative 3. So from here I can simplify each one. So 20 divided by 15, we need to think of a number that goes into both of those. In this case it's 5. So this one here is going to be 4 over 3. Now when we have c to the negative 3 divided by c to the negative 1, what we actually end up doing is subtracting these powers. So from that, what we actually do is go negative 3 subtract negative 1, which is like negative 3 plus 1, which becomes negative 2. Because I get the answer of negative 2, I actually can just put c squared on the bottom with a 1 on the top. Because when I have something like this, this is the same as c to the negative 2. I do the same for my next one. 2 subtract negative 3. Now it's going to become plus. So 2 plus 3, it's going to be 5. Because I get an answer of positive 5, d5 on 1. Then I just do my multiplication across. So 4 times 1 times d to the 5 equals sign equals 4d5. 3 times c squared times by 1, 3c squared. And that is my final answer just there. The next one I'm going to look at, question 4. This is a simplifying surds question. I'm just going to zoom in a little bit here. What we have here is, this question is very similar to if we had something like this. 7x take 5x. I'll just move this one across a little bit. Take 5x plus x. Because each of these are all like terms because they are all the square root of 3. So what I can do is I can simply add or subtract the coefficients. So in this case, I have 7, take away 5, which is going to give me 2, plus 1, 3 root 3. Moving on to question 5. This one's a little bit different because I don't have any like terms, but within these surds here, I can actually simplify them before moving on. So what I need to look at to start with, I need to think two numbers that multiply to equal 48, one of which being a square number. Now in this case, I know that 5 stays there. Remember there's like a times in between each of these, times by the square root. Now I know that 16 times by 3 is equal to 48. The reason I chose 16, it's the biggest square number we can use in this example. Take away 2, this 2 stays here for now. Then I need two numbers that multiply to equal 12, one of which being a square number. So we're not going to choose 2 and 6, we're going to choose 4 and 3. 4 times by 3. From here I can then simplify this a little bit more. This 5 still stays here, just transfers straight down. Times by the square root of 16 times by the square root of 3. Subtract 2 times the square root of 4. And there's little times in here. Times by the square root of 3. Now we can start to simplify. The square root of 16 is 4. So it's going to change to 5 times 4 times the square root of 3. Subtract, now the square root of 4 is 2. 2 times 2 times the square root of 3. 5 times 4 is 20, root 3. So it's going to change to 20 root 3 minus 4. 2 times 2 is 4, root 3. Then this is just like the question before. I now have a root 3 and a root 3. So I can just simply do 20 minus 4, 16 root 3. And that is my answer. So from 5 times by the square root of 48, take away 2 lots of the root 12. This then becomes my final answer. Next one, very last, question 6. This one's a little bit tricky. Remember, with any of these, this 5, it's going to affect the 3 and it's going to affect the B. Same with this 2 over here. This 2 is going to affect this and it's going to affect this. So let's do that first. This is going to change to A to the power of 3 times 5, B to the 5 over. Now there's no power of 5 to any of this bottom stuff, so that all stays the same. 5a cubed b to the negative 2. Then I am timesing that by this 2, it affects everything. So a to the negative 4 times 2 over b to the 6 times 2. I then can start to simplify this. So 3 times 5 is 15. So we end up having a to the 15, b to the 5 over 5a cubed b to the negative 2. Same with this side, I can simplify it down a little bit. Negative 4 times 2 is 8. A to the negative 8, remember negative and a positive make a negative, over b to the 12. I can now simplify this down even further. So if I look back over to this side over here, I have a 5, I have no other numbers. So what I can actually do is I can just go 1 over 5 times by a to the 15 over a to the 3 times by b to the 5 over b to the negative 2. All I've done is split this up into its letters and numbers. Then what I'm going to do, because there's no a's on the bottom, I can actually just go a to the negative 8 on 1 times by 1 on b to the 12. And then I can start to simplify this. So 1 over 5 is just 1 over 5 times. I've got 15 here, 3 on the bottom. So they're all going to disappear. I'm going to take 3 off this. It's going to become 12. So a to the 12, this doesn't become 0, this becomes 1. Now there's 5, subtract negative 2, so 5 plus 2, which becomes 7. So b to the 7 on 1. Remember, positive numbers go on the bottom. If it's a negative, we leave it as a positive. It just goes on the bottom of our fraction. A to the negative 8 stays the same. Oops, let me just change that colour. Times by a to the negative 8 on 1 times by 1 on b to the 12 rather. Now, this is where we start to simplify even further. So first of all, I've only got a 1 and another 1. There are only 2 numbers, so I'm actually going to put a number there. Then I have a12 times by a to the negative 8, and we add our powers. 12 plus negative 8 is like 12 take away 8, which is going to be a to the power of 4. So and there's no other b's on the top, so I'm going to be left with a to the power of 4. Then on the bottom I've got 5 times 1 times 1 times 1. I have my b7 on the top as well, because I can't simplify those b's yet. b7. Then over 5 times 1 times 1 times 1 times b to the 12. b to the 12. And my final step, I've got no a's to cancel that out with any further, so I just leave this as a to the 4, b to the 7, b to the 12. They're all going to disappear. I'm going to take away 7 away from 12, which is going to leave me with 5. A to the 4 over b to the 5. And that is my final answer just there.